they call it approximate integration. Other textbooks will call it numerical integration. And the idea is there are lots of integrals that you just can't really find antiderivatives for. Like, for example, if you've heard of in statistics of the normal distribution, to find probabilities in the normal distribution, you basically have to do integration, but it's a function that you cannot integrate. And so it's like trying to integrate this, e to the x squared. There's just no expression for this in closed form. Okay, so you couldn't like make up a new function and say, oh, we declared this new function to be the antiderivative of e to the x squared. Okay, but it's like just creating a new function. And so, but how do you find values? And this is related to the normal distribution. So how do you find values of the normal distribution? Well, you do approximate integration. You can find these values very, very efficiently and very exact as long as it's integrating over a specific integral by using numerical methods. Okay, so probably the most powerful one that we're going to learn would be Simpson's rule. And I'll explain what that is, but these are basic, and then we got some basic ones here. We'll come back to this page here in a minute. Okay, but first of all, it kind of goes back to when we were first learning about integrals and what they are. And the important thing to remember is that an integral or a definite integral is, that should be definite, not the definition. Definite integral is the area under the curve. Okay, or if you have something that dips below the x-axis, then it's the net area. So it's the area above the curve minus the area below. The area between the curve and the x-axis that's above the x-axis minus the area under, okay, or net area. Probably be more like it. So like if you had a function like this and you want to integrate from here to here, then it would be this area plus that area. So that one and that area, and this is, let's say that's area 2. So it'd be 1 plus 3, those areas, minus the area 2, because the 2 is under the curve. So the areas here are above the curve minus the area under the curve. So that's kind of how that works, okay? So when we were first learning about it, we learned about things like this. This is 1A. Use the graphs to find L2, R2, and M2. Now, L2 was using left endpoints, okay, left endpoints. And for this particular problem, oh, I didn't put it down. I think we're supposed to use n equals 2. Oh yeah, there's 2's right here. So yeah. So that means, what the 2 means is you're going to split it up into 2, this interval from 0 to 4, because we're looking at the integral from 0 to 4, right? Okay, so you're going to split up into 2, this interval from 0 to 4. We split that interval up into 2 pieces, one going from 0 to 2, another one from going 2 to 4. Okay. So L2, which we'll do in red, is for this first interval, right here from 0 to 2, you choose the left endpoint, which is 0, and the value at the left endpoint, okay? So this rectangle here is the representative there for this interval. For this interval from 2 to 4, you also choose the left endpoint. And so you're going to get this. Okay, so L2 is going to be the sum of these the two areas of the red rectangles. Okay, so L2 is going to be, okay, so this is, the height is 1, and the length is 2. So that's going to be 2 times 1, or we could write f of 0 plus, and this other length is 2 times f of 2. So this is using the left endpoints. Okay, and so that, of course, f of 0 is 1, and f of 2 is 5. Okay, so that's going to be 2 plus 10, which is 12. Okay, so that will be 12. Now, we use the right endpoint. So for this, the first interval, we would choose the right endpoint instead. So the length is still 2, but you're going to choose f of 2 instead of f of 0. And then you're going to choose the right endpoint here, which is f of 4, which is 4. Okay, so these are right endpoints. Okay, and of course, f of 2 is 5, and f of 4 is 7. So that's 10 plus 14, or 24. Okay, so that's going to be 24. And then for the third one, the m, this is midpoint. Okay, so these are the midpoints of the intervals. So you're gonna, so 1 is the midpoint. And here it's 3 is the midpoint. So using the midpoints, and f of 1 is, wow, it's right there. So it's a little bit more than 3. Maybe we'll say 3.2. They're going to be forgiving on this, I think. And then f of 3 is using this endpoint. Okay, so here you're using that. So you're looking at, for the midpoint one, you're looking for this rectangle here. So that the length is 2, the height is about 3.2, maybe 3.2. F of 3 is, the height looks like about 6.4 maybe. Okay, so this is going to be 6.4 plus, let's see, 2 times 6.4 is 12.8. That adds up to 19.2. I think that will probably work. Let me test that value there. I mean, if you eyeball it, you might come up with a different number, but 9.2 is going to work. Okay, and then the second part, B, are these underestimates or overestimates? Okay, so the red rectangles, now the actual integral is going to be, oh wait, I forgot to draw this rectangle here. Okay, so the actual I forgot to draw the right ones too. Oops. Okay, so the right one, I forgot to draw this right one. The right one was up here because you're using this point here, and then you're using this point here. Okay. So the actual integral will be the area under the curve. So all this area here. Okay, that's the actual integral. Now, L2 using the left endpoints, since this area of this rectangle is less than this area, it's contained in this area here. And the area of this rectangle is contained in the area under the curve, then this will be an underestimate. And so that's underestimate. And then R2, because if using the right endpoints, then the rectangle, this rectangle here, this contains this area under the curve. And this rectangle here, this green one, contains the area under the curve. So this will be an overestimate. And now this is the M2 is a little bit tricky because here you have some area above that's not contained in the rectangle, that it is contained in the rectangle, but then you have this area here that's supposed to be counted that's not. But those seem to be about the same. Okay, maybe those are the same. Over here, this area seems to be more than that area. And this is area that should be counted, that's not counted. This area is, no, I'm sorry, this is area that was counted, that shouldn't be counted. And this is area that wasn't counted, that should be counted. So it looks like the area that should have been counted, no, the area that was counted, that should have been counted, that should not have been counted is more than the other one. So that seems to be, that indicates that it's an overestimate. Okay. Okay, so the area, so it has more area here and here that was counted that shouldn't have been counted than the other way around, than these areas here. Okay. So I'll just say, let's say that's 1 and 2, and that's 3 and 4. Okay, so that's because 1 and 2 are greater than 3 and 4. They seem to be greater than 3 or 4, okay? Okay, great. Now, let's take a look at these right here. Okay, so first of all, the trapezoid rule. Okay, so what happens there is, let's say that we have a curve like this. Okay, let's say we want to find the integral from A to B. Okay, so this is the trapezoid rule. Okay, so what happens is, I like to call it actually the sideways trapezoid rule. Wait. Because it's a sideways trapezoid. Okay, so what happens is you split this up into equally spaced partitions. Okay, so like you're usually given an n, and so you take this total length and you divide by that n. Okay, so for example, here, n was 2. And B is 4, A is 0. So H would be 4 minus 0 over 2. Okay, that's A minus B over N, which is 2. And that's the length of each of these subintervals. It's length 2. This is length 2. This is length 2. Okay, that's our H. H is going to be the length of the subintervals. So here, oh, wait a minute. Oh no, that's fine. So, so what happens with the trapezoid rule is, let's say A is here, the B is there, and I said 1, 2, let's see, 1, 2. This would be n equals 6. Okay, and so this distance here, from here to here, H would be B minus A over 6. Okay, because n is 6. Okay, so with the trapezoid rule, you're taking this point here and that point, okay, and then just like putting a line between those two. And you're taking the area of this trapezoid. Okay, this is a trapezoid. This line is parallel to that one, but it's sideways. Okay, so if you so usually you think of trapezoids as being like this, right? Where these two lines are parallel, but it's like this, okay? Where these two lines are parallel, these two line segments are parallel, and then and the top one's whatever. Okay, and then from here on this interval, you're looking at that one. That looks more like a rectangle. And this interval, you're looking at that. This interval from there to there, and so on. Okay. And this interval from here to here. Okay, so you got these different trapezoids, and the idea is to find the area of those. Okay, so the area of a trapezoid is equal to f of the previous point plus the f of the f of this. So if this is x n plus 1 and this is x n, then this area here would be the sum of the distances would be the average of these two times h. Okay, so the average of these two heights times h. That's going to be the area. Okay, so what happens is this h over 2 gets factored out like that. This h over 2 gets factored out. Now you're basically, it's h over 2 times this point plus this point again, because this point here is the right endpoint of the first interval, and it's the left endpoint of the second interval. So that gets counted twice. Okay, that's why there's that 2 there. Okay, because it's the left-hand point. This point is only the left-hand point of the first interval, and so it only gets counted once. Okay, so that's the pattern. And then there's h over 2. This h over 2 is this piece here. Okay, so there's the first one plus 2 times the second one, and so on, like that. Okay, let's do an example, and that's part C here. So this is called T2. It means use the trapezoid rule with 2 intervals. Okay, so we have, those are the 3 points that we're looking at. So first of all, h would be, okay, which is, I'll do the formula out. So h is 2, and those are the lengths of each of the subintervals. Okay. So you have h over 2. So this is what's going to happen here is it's going to be h over 2 times f of the first one plus 2 times f of the next one plus f of the other endpoint, like that. Okay. So basically we're going for that trapezoid plus the area of this trapezoid. Okay, and the area of this trapezoid is h over 2 times f1 plus f2. The area of this trapezoid is h over 2 times f2 plus f4. f of 2 plus f of 4. Okay, so, and h is 2, so that's 2 over 2. F of 0 is 1. F of 2 is 5. And f of 4 is 7. Okay, so that's 1, so that's just 1 plus 10 plus 7, which is 18. So 18. Now I is equal to the integral from 0 to 4. And because this area here is this trapezoid, because the curve kind of has a curvature. It's concave down, right? So what that means is that there's some space in here and here that wasn't counted, that should have been counted. So that means that the actual integral would be bigger. Okay, so that means 2 in this case is less than I. And in complete order, the lowest one, the smallest one's going to be L2, of course, that's the left endpoint. The largest one is the right endpoint. Let me see. So it says put them in order from smallest to largest, increasing order. So that's the smallest, L2, because that was just these little rectangles that are down here. The next smallest one is the midpoint and the right and the actual integral. Okay, so let's see, the midpoint and the right endpoint were both larger than the integral. So that means that, and then the trapezoid's the only one that's smaller than the integral. So it's like that. And we know that trapezoid is smaller. And then there's M2 is also larger than the integral. Okay, so that should be the answer there. Okay, so that's the trapezoid rule. And so the important thing is to remember that it's like, that this pattern here, f of, is just 1, 2, 2, 2, and then a 1. And in this case, the special case, we had n equals to 2, so it's just 1. Everything in here is 2, then the last one's 1. But there's only 1 in the middle, so because we only had 2 subintervals. Okay, so that's the trapezoid rule. Okay, Simpson's rule is kind of interesting. What happens there with Simpson's rule is it's very ingenious what they do. Another way that you can think of the trapezoid rule is just taking these 2 points and finding the line that goes through those 2 points. Okay, and then finding the integral under that line. That's another way you could think of doing. So like, replace this segment from here to here with a line, and then integrate from across from this subinterval, find the integral of this line, okay, which will be the area under the line, okay? Plus, and then just do lines for each one. Just basically just doing line, and then integrating under each of the lines, okay, and then adding all those integrals up. And that's going to be the trapezoid rule, okay? So maybe I should write that down. So another way to think about it is trapezoid rule. Okay, so find lines and integrate under the integrate and add up. Okay, so you're finding a line, integrate on this interval below this line, on this interval below this line, on this interval below that line. Okay, that's trapezoid rule. Okay, what Simpson's rule does essentially is you find quadratics. Now, the way that you do it is you take these 3 points here, okay? Through those 3 points, there's only going to be one quadratic function that goes through those 3. There's only going to be one. So essentially what you're doing is if you were to find that quadratic that goes through these 3 points and integrate it, and add them up. Okay, so the integrating across those 3 points, add that up. If you were to find, so that's a long process. It could be a long process to figure out what quadratic goes through these 3 points. It could be a lot of work. It actually turns out that the ingenious thing is you actually don't have to find the 3 points to know what the integral is going to be. You don't have to find the quadratics to know what the integral is going to be. Okay. It's going to be this. Okay, so h would be the h over 3 times f of the first point plus 4 times f the second point plus f of the third point. Okay, it's actually going to be that. That's going to be the integral across that segment there. Okay, so you don't actually have to find the quadratic. The integral, if you were to find the quadratic and integrate, you'd get this. Okay, and so that's why in the formula here, you have the h over 3. You've got you start out with just 1, 4. It's actually 1, 4, 1. But then the next interval is going to be 1, 4, 1. So that means that's going to be a 2. And the next interval is going to be 1, 4, 1, and so on. And so you got, and then 1, 4, 1, and then finally 1, 4, 1, the second to last interval, and then the last interval is 1, 4, 1, like that. Okay, so that's kind of how that works. Okay, you don't necessarily need to know that that's where that comes from, but that's nice to know. The main thing is just how to apply it. Okay, so let's go ahead and do this integral here. Now, there's going to be lots of calculations when we do these. So we have n equals 10, and we're supposed to find the trapezoid rule, the midpoint rule, and Simpson's rule. We're supposed to do each of those on this interval here, on this integral. Okay, so e to the x over 2 plus x squared for n equals 10. Okay, so the function is this. N equals 10. Okay, so if n equals 10, then the intervals, okay, so b is 2 and a is 0, okay? So h, this h right here, we got from this formula here, it's b minus a over n. That's going to be 2 minus 0 over 10. So that's going to be 1 over 5, which is 0.2. So the h is going to be 0.2.
Is it easier to do with decimals or with the fractions?
Decimals.
Okay.
Yeah. Okay. Now, hopefully you guys have access to Excel, because I'm going to do this in Excel to kind of show you. But I'm going to do a lot of preliminary stuff to kind of show you what's going on. So x sub 0 is going to be 0. x1 will be 0.2. x2 will be 0.4. So basically, you're integrating from 0 to 2. And this is x0. x1 will be 0.2. x2 will be 0.4, and so on, okay, 0.6, and all the way up to 2 is what it's going to be. Okay, here's our function right here, not under dx. Okay, so here's our, this is what the intervals are going to be. Approximating this is going to involve finding values at the different points, at each of these points, and then adding them up in this fashion. Okay. So I'm going to so that kind of understand what's going on here. I got this 0.0, 0.2, 0.4, 0.6, and so on. For the trapezoid rule, I have the weights. One, two, two. All these are going to be 2s, and then the last one's going to, and then 2 corresponds with the 1. Okay. And then the second to last one will be 1.8, and that will correspond with 2. Those are the weights there. Okay. So then I have this h over 2. H, that's h. So h over 2 will be 0.1, but let's not worry about that. Okay. So CXL. And I'm going to show you how to do the file, and then I'm going to call it 7.2a, 2 and 3. I will upload this to Canvas, okay? But I will show you how this works, okay? So remember, this is our function. These are the points that we're going to go through. These are the x sub n's, 0. These are the weights for the trapezoid. This is trapezoid weights. What the? We'll do Simpson's rule and the midpoint rule as well. For Simpson's rule, we're going to use these same points, but the weights are going to be 1, 4, 2, 4, 2, and so on. And then like that. It's going to be 1, 4, 2, 1, 4, and so on like that. Okay. And then for Simpson's rule, it's h over 3 that you divide by. So 0.2 divided by 3. Okay. So here we are in Excel. So I have a blank spreadsheet. Okay, like I said, these are going to be, I'm going to have my x sub n's here. I'll write x sub in there. And I said 0, 0.2, 0.4, 0.6, 0.8. There's probably an easier way to do this, but I'm just going to like type them all out like that. Okay. Now I'm going to, right here, I'm going to write the function values, because those are also important. Okay. And so if I go equals, and the function, remember, was, dang, what was the function? Okay, it's e to the x over 2 plus x squared. So for e to the x, type in exp. And then in parentheses, I'm going to put A3. Okay, that will use whatever's in this cell. Okay, exp means e to the x, and then the A3 would be this. This is the value of x. It's going to use 0, that one. And then I'm going to divide by, and then put in parentheses, put 2 plus A3 squared, like that. Okay, so I get that. Okay, and you can see it up here. And I can double click, or I can grab that and drag it down there. Okay, so those are all the function values right there. Okay, now I'm going to put trapezoid weight. And remember, those are 1, 2, 2. All those are 2s and 1. Okay, and subinterval estimates. Okay, so what that one is I'm going to take, I'm going to, H is 0.2, and I'm going to divide that by 2. Okay, so this represents H divided by 2. And then I'm going to multiply by the function value and times the weight. Okay, so times B3 times the corresponding weight, which would be D3. And that will give me the value there. And then I can like drag this down and it gets all the values. And then down here, I'm going to just calculate the sum. So sum of E3 through E13. And that gives me there. Okay, now that is the answer. This right here is the answer for the trapezoid rule. I need 6 decimal places, so you might have to like make this wider to make sure you get 6 decimal places. Or you might have to like, you also might have to like go into your Excel settings and make sure that it's going to give you at least 6 significant figures or 6 decimal places. Okay, so you might have to go, where is that? I think it's in, oh, what is it? Format cells maybe. Okay, so and then might have to like go through here and make it a number and have it give you like a whole bunch of decimal places or something. Okay, something like that. If you do 6 decimal places, then there we go. Okay, so that number there is the answer to the trapezoid rule. Okay, that one right there. Okay, so that's the first answer. Now I'm gonna do Simpson's rules weights. And then those ones, remember, were 1, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, and then, wait, no, 4, 1. The last one is a 1. And then subinterval estimates. Okay. So Simpson's rule was you're taking H, which is 0.2 in this case, and dividing by 3. That's the Simpson's rule formula. Times, and then I'm going to go B3 times G3. Okay, so I'm multiplying by the function times its corresponding weight times H over 3. Okay, and that gives me that. A typo, what the? How is that a typo? Maybe I didn't put the equal sign at the beginning. Okay, so those are all the values, and then here, and I add up H3 to H13. Okay, and I have 1.781557, which is the answer for Simpson's rule. That's actually part C. Okay, and so now, so that's the Simpson's rule there. Okay, now I'm going to do the midpoint rule. Okay, so now I'm going to find the midpoints. And the midpoints, if I go back to the document, okay, the midpoints are going to be, see, these are the intervals right here, 0 to 0.2, and then 0.2 to 0.3. So the midpoint there is 0.1. So it's 0.1, 0.3. Those are the midpoints right there. Okay, so I'm going to let me say X of n here. So this time they're 0.1 with the midpoint, 0.3, 0.5, 0.7. And those ones, those are the midpoints. And then maybe the easiest thing, instead of typing that formula in again, I just can go down here. It'll give me a bunch of errors. I'll delete all those. Put that in there. Yeah. Just making sure. So exp over 2 plus x squared. Yeah. And then all the weights are 1, so I don't have to do that one. So I'm gonna over here for subinterval estimates. It's going to be the length of the interval, which is 0.2, times the height of the interval, the height at the midpoint, which would be B18 in this case. So here, since it's not right next to that cell, I got to drag it down, and then there's this, and I take the sum of those. So E18 through E27. Okay, and then that's the answer for the midpoint. Except you want to round it off to 6 decimal places. I guess I can do that by just bringing this over here. There you go. There we go. If I just also you can like, if it's going to more decimal places, then you can make it just 6 by adjusting the length of the width. Okay, and then that was number 2. So you got the answers there. Okay, number 3 is more of the same, except we're integrating from 0 to 4, and n is 8. Okay. So for this one, A is 0, B is 4, N is 8. So that means our H is going to be 8 minus, no wait, what am I doing? 4 minus 0 over 8, which is going to be 0.5. Yeah, and again, probably decimals are better. That's why I'm using decimals in this case right here, because there's going to be a lot of calculations. Okay, and then just do the same thing. This is our function right here. Like that. Okay. So let me go over, I'll just show you really quickly how to do it in Excel. Maybe I can just copy the whole thing. Or I can just copy the whole thing and then adjust. So instead of the intervals are going to be 0, 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, and then that's it, right? That's no more there. So I can just delete all that. Let me do this. I'll delete these two here. Delete those two. The weights are going to be, this is going to be 1. That's also going to be 1. The function is going to be, instead of this, the function is, what is it? It's the square root of x, so square root is sqrt. So the square root of a3 times, and then cosine of cos of a3. Wait, I should put equals. What am I doing? Equals that. Okay, so there we go. It's equal to that. And then just drag that down. And it adjusted, wait, I didn't drag it far enough. Okay, so it adjusted the these values here, but let me see. The subinterval H was it's not 0.2 anymore, it's 0.5. And the same thing with this H right here, it's not 0.2, it's 0.5. Let me delete those two columns there. Okay, that's the answer for Trapezoid Rule. That's the answer for Simpson's rule right here. I should probably 1, 2, 3, 4, 5. Yeah, that looks like if you round it off, this 9 rounds that up to 2. Okay, so that's the answer for Simpson's rule. This is the answer for Trapezoid Rule. For Midpoint Rule, okay, so if your intervals are so for the Midpoint Rule, let me think. Okay, so I come back over to here. Okay, so for the trapezoid and the Simpson's rule, we use 0, 0.5, and so on. For the midpoint rule, we're going to use the midpoints of those intervals. So from 0 to 0.5 would be 0.25. So we use 0.25, and then the next interval is 0.75, and then the next interval is 1.25, and so on. Okay, so we're going to use those points for the midpoint rule. So 0.25 and then 0.75, 1.25 and then 1.75, 2.25, 2.75, 3.25 and 3.75. And then same thing, we've got to change the function. So I'll just drag that down. It will put the new function in there. Delete those. Change that there. Okay, subinterval estimates. It's 0.5 times that. So I change that and then drag that down. And this is that the answer? Yeah, that's the answer right there. It says to do 6 decimal places, but that's it. The next one is a 0.